Steve Basic Architect. Check this out. Yeah. We are up here in Madison, Maine. Timber HP. And guess what we're doing? We're getting a tour of the Timber HP factory, where they make the timber fill, they make timber bat, and they will be making timber board. So this is quite a story, so stay tuned. Process engineering, there's not much like it. A lot of ingenuity happening on the other side of those walls. So without further ado, let's go check it out. All right, so took a little walk down the driveway. You can see the falls there, but there's actually something quite interesting happening here. Those two falls are basically overflow. What magic is really happening is what's happening in that brick building. There's hydroelectric turbines there. You can see under the building, you can see the water coming out. Let's see if I can't zoom in here. You can see the water coming out the underside of the building there. And so what that is that's generating power for the whole plant. Now I'm told right now, because they're not running at 100% capacity, that this is doing more than what is needed to run the whole factory via hydroelectric power. When they have all three lines, the timber fill, the timber bat, and the timber board, that this is probably going to be up in like a 95% range, and they might have to get a little power through secondary means. But for the most part, this whole plant is developing a wood fiber insulation that has a negative carbon content, and it's all being developed or fabricated, manufactured, whatever word you want to use, via hydroelectric power right here on the river. So actually quite an amazing story of, sustainability, if you will. I hate using that word, but nonetheless, lack of a better term, this is just a really good example of how you have a company like Timber HP that not only cares about the product they're making, but it also cares about how they're making the product, the things that go into the product, and exactly what that eventual product is. So, kudos to Timber HP. Let's get on with the tour. Check this out. Yeah, big pile of wood chips. So this is where the whole process starts. These are all the chips that have just been received. You can see, you got big machinery moving these wood chips around and bringing them in for the process. But this is pretty much where they get stored until they're needed for process. They arrive here at about 40% plus moisture content. So if you like the smell of spruce pine fir, man, stand here for a few minutes. This is really good smelling stuff. But here, I just grabbed a handful. You can see these are the wood chips. So these are all just they're going to go get processed in there for fiber, but they come here as virgin chips. Basically, they're a waste product, logging industry and such. But they get I don't know. They said right now they're getting about 3 or 4 truckloads of chips a day for processing, and so anyways, let's move on. So we saw the big trucks doing big work. Spin around here and you'll see what kind of work it's doing. These are the hoppers. You can just see the wood chip piles. The guy in the front end loader, this is his job to keep those full. Now you can see there, those hoppers fill this belt, and that belt goes into what I'm told is a sizer. So you can see on this side, it's spills out the stuff that's undersized, and I believe the other side is the oversized stuff. So they really need a specific size that this material is required to be for processing. Yeah, so you can see here, this is all, you know, pretty big stuff. So this machine only sends stuff up the belt, and you can see there, long conveyor belt up into processing. That's kind of the, let's say the middle 60-70% of sizing. So to the left is the unders, to the right is the overs, and the just right, well, that goes up. All right, so I'm at the bottom of where those chips come down. So they come down here inside this large metal tube. They're basically getting cooked, and they're adding steam to it to soften the wood chips. And then what's happening in that machine right there, there's a series of metal plates that are very close together, and they're taking the wood chips and basically grinding it into a fiber, and it's coming out that pipe there, and then it goes up these lines here, and that's where it's getting treated with borates and such, and they're off to other processes. So we'll just follow along.
So I didn't really get to it when we were down here before, but this little brew house right here is where we're mixing those borates.
Okay.
And so that gets run over and then brought
What
in.
comes in these?
Yeah, those tubes. That's DOT, disodium octaborate tetrahydrate.
All right.
I think is what it is.
Yeah, that's where the borates come in. I get
Right.
it.
So dry, we take that, it gets brought into a hopper, and then
Does it turn into a liquid, or?
we buy that borate in particular because it liquefies fairly well at a particular temperature. So we get that mix, and then we're dosing based on the speed of production around
Through like aerosol.
It's actually just like an injection port on a somewhat wet stream of fiber. And so we're adding a little bit more moisture, but in the turbulence as it gets into the drying system, which is that big, crazy jet engine fans and all the conveyance over to the two cyclones, in that 30 seconds or so, we're getting something that's more than 30% moisture down to about 14% by the time it goes into the bag. So what's really nice about it, what I think we've done so well with our fire classification being so low with the flame spread, is that we are coating that material at best, if not actually baking it into the fiber. So now we've got a liquefied borate, a lot lower concentration than you would with a dry cellulose process, coated right onto the fiber. So threshold of 25 to have a flame spread of 25 to get a Class A fire resistant product, and we ended up with about 5. So very, very low flame spread, very, very low, if not zero smoke developed for that test.
Right, so down on the factory floor you can see there's a whole bunch of bats there, but let's talk about how we get it in the bat. We got these giant tubes there that is basically feeding this hopper up above here. You can see the hopper there filled with a ton of wood fiber. Almost looks like it's getting blown around. Probably getting, like, I won't say aerated, but basically getting it nice and fluffy so that they can mix it in with the bat. That falls down into the hopper. You can see there's a pipe right there, that round pipe, and that drops down, and this is pretty much where that is getting formed. You can see those doors open and closing. And stay here. See, it gets dropped down, all the wood fiber inside there, and then basically it opens, so you see that it presses back up. And Then it comes in here, it gets compressed. Wait for the next one, we'll follow it along here. So you see, I don't know, it's probably about 22 inches. It gets compressed to about 14, and then it gets baled. Some plastic there. And then you can see here, coming down, got the whole roll of the plastic liner. And yeah, pretty cool little turning mechanism. You can see it here, watch. It basically spins the bale and then sends it down the line here for loading up and palletizing it. So we'll get a second look at this. Pretty cool little process on how this stuff gets baled. That gets sealed up there. Sides get crimped. I'm assuming they get heat welded. It's on its way. You see a little weight there, just constantly keeping that the bale liner there in tension. It's got that little weight. So I don't know. Process engineering just fascinates me. So here you can see this is kind of the end of the line for the timber fill product. You can see on the back side there, or let's actually start here, you can see this one's fully wrapped and palletized, and it's going to get lifted up, and this will be the first time that a forklift handles it, which is actually pretty impressive. So you know, you're not wasting a lot of movement with tons of forklifts moving product through the factory. It's all moving via conveyor belt, and then it comes here and he'll grab it, and then you can see behind him it's getting stored there. But if we go down here, this is the machine that's doing the stacking, and let's see about what this looks like on the other side here. So you saw the timber fill bats, you know, they came out of the packaging machine. So I'm just on the back side of that line, so you can see them coming down through here. And again, this is their timber fill product, and you can see it looks like they're looking for 3 in a row. Actually, that's 2 there. But they go down there, and it's all automated stacking. So really cool stuff. Let me go back on the other side. You can see pallets here are being fed in. But on this side, you can see the pallets here, they're getting stacked. And as they spin, they're getting wound in poly and basically getting wrapped again as a palletized unit. Just really cool stuff. And then that'll stop, and you can see it's on the right hand side right there is where the poly, it's stored inside here where it's getting wrapped. But the palletizer, if you will, or the elevator, I'm going to call it, it might have a different name again, but basically that's loading the bales on there. It's what a neat little automated process in how you can see here, these are just all the different fills. It looks like it's about a 24-inch roll of poly that is doing that. So you can see the the bales as they come, they get stacked, and then they get pushed up against it. And then I'm assuming that'll move up. It's going to spin around again, and you can see on the right side that keeps going up and elevates, so it just continuously wraps that timber fill. And what are we, 4 high there, and it looks like 1, 2, 3, 4, 5, 6, 7. That's about half a pallet right there. It goes up to a full 8 high, and like I said, gets put by the forklift, and then you can see being stored in the warehouse there, just hundreds of bats.